research on the what's going on out there and then bringing that to you as well as, of course, my opinion every month. So that is a big purpose, just to be able to gather, network, collaborate, be with like-minded people. And so here we are right here. Feel free to use the chat to talk to each other, um, which is really one of the benefits of being here today. You can, in a moment, we'll see where people are from and what grade levels you teach. But the other main purpose of Saturday Math, and this has always been the case in the 8 years that we've done Saturday Math, is the bottom line. If students have number sense, we can take off with whatever initiative and resources are thrown at us. So the overall goal that has always been on Saturday Math is improving number sense. That is our foundation. So I'm going to put number sense here. There's a secondary goal, and over the last couple of months, we've launched an initiative called Math Testing Secrets that we have an entire course for now that we're very, very proud of. But in that testing secrets, we say that there are two barriers to increasing test scores. And the barriers are students having a lack of number sense, but also a lack of notation. And there are some of my favorite notations that have scaled student achievement that we use that are not explicitly stated in the standards, but are very much related to the standards. Some of you can probably guess one of my favorite notations. Should I have you guess? I should have you guess. What's one of my favorite notations that relates to a task that is the utmost of importance for understanding numbers and having number sense and improving number sense? Natalie, of course, you are always transplanted here to give us the exact answer. Notation of square root. We have no idea how essential notation of square root is. That's the one I'm going to land on today. There are other notations that are absolutely essential, because part of what is the difference between a student passing an end of year math test and almost passing an end of year math test most often is the notation that is used and the lack of understanding of that notation. Now, I'm coming out of the gate talking a lot about testing as if like testing is the be all end all. Well, no, it's not. If you all know me, you know it's not. But we want our cake and we want to be able to eat it too. So I want kids to have great, rich, complex, accessible math experiences in the classroom on a daily basis. That's what I advocate for. I empower teachers to create these experiences for students because I cannot personally create these experiences for every student out there in the United States. But with your help, I can do that. So my main goal and mission and vision is to empower and inspire teachers and teach teachers how to create these rich, complex, accessible math experiences that target all students, and especially students that struggle and students with disabilities. Having said that, if we're going to do that in an effective way, the test scores should show it. So, and I mean, that's what we're judged on. We're judged on the test scores. So why not have a goal of these kids can? And I know these kids can, because if any of you know me, you know that we have taken cohorts of students from 27% passing one year to the next year, 65% passing. We've taken cohorts from 65% passing to 86% passing. We've taken cohorts of students from exhibiting bell curve results, meaning bell curve, this is 50th percentile. So average is 50th, really from 40th to 60th percentile on bell curve on a true standardized test. Now, I have to get on my soapbox for just a minute. We have for years, even from the time that I was in school, we've used very high rated, credible, standardized testing companies that this is all they do. And I'm going to give two examples of those: the Iowa battery and the Terra Nova. Okay. I don't know if you have heard of those or know those or whatever. Those are true standardized tests. They're competitive companies. They're two different companies. But the Iowa and Terra Nova, I have an immense amount of respect for. An immense amount of respect. The same amount of respect I have for the ACT and SAT. Again, ACT and SAT, two totally different companies, two totally different platforms, competing interests, whatever. But it's always good to have both. And I don't have, a preference one way or another. I think we can use both of them to our advantage. But the Iowa and Terra Nova used to be the be all end all. A district would pick one of them, and either every year or every 3 years or every other year, students would take this standardized test. And the reason that I loved how standardized it was is it is national. Like, it didn't matter if you were in Pennsylvania or Arizona or whatever. It was usually one of those two options. And what the Iowa and Terra Nova did was, yes, it gave you an achievement percentile, not a percent, not a passing. There's no passing. It gave students a score based on percentile for achievement. So there were subject achievement pieces of it. And if students scored anywhere between the 40th and 60th percentile, spot on average, spot on average. Fantastic. Which is why, and I'll just give you an example from the state of Ohio, which is why in reading now we have what are called RIMPs in reading. They're individual plans for reading, even of kids that are not special ed, not on IEP. But school districts were able to pick and choose what percentile ranking was the maximum for students that have deficits. Too many school districts picked 40th percentile. The problem is 40 is right at the bottom of average. So we're doing a lot of extra work for these kids. And what was happening in schools, what is happening in schools, is some of those kids that are like 32nd to 40th percentile, we're creating these plans for them, but they have been passing their reading on the state test. So there's this disconnect. The reason is, I believe we've gone down a very, very skewed road for data. So I just want to enlighten us this morning on what data we're using and how we're using data, and how the data has shifted to become much more ineffective in recent years. So Iowa Terra Nova, the results of these things used to be outstanding, spot on for kids, okay? Now, the reason I bring this up is I'm trying to show you in cohorts that have used the model that we present in all of our sessions, is we've been able to scale exponentially the achievement of students, not just their achievement, but their test score results. So when we look at percentile rankings, when we were using Iowa Terra Nova, we had a cohort of students that no one in this certain cohort scored below the 70th percentile. I mean, we literally broke the bell curve with one of our cohorts. Absolutely crazy. The other thing I want to say about Iowa and Terra Nova is a really important piece of them was the cognitive ability test. So you would get a cognitive ability, students would get a cognitive ability score, which was like IQ score, okay? And on that cognitive ability score, 100 spot on average, but really average went from 90 to 110. And this cognitive ability score, scoring high enough, would accurately determine gifted brains and accurately determine students, our 70s kids that had severe brain disconnects. And this is what we've used forever and ever and ever. Okay, so let me make 2 points on this. One point on this is we have scaled math achievement using part of what I'm going to tell you today, because going back, I'm talking about the big overarching purpose of Saturday math is improving number sense. We know that with testing, we want to improve notation sense. And I just want to show you some of the things that we've been able to do, because a big purpose of Saturday math is to empower and inspire us to go back, and when we know better, we do better, so that we can all be equipped to scale math achievement in these same ways. So I wanted to share some of that data with you. So that's one piece, is the purpose of Saturday math, and it really starts with number sense but dwindles down to these other things. And since we're in testing season, I want to bring those things to light. Now, here's the other point. I wasn't even going to talk about this today. I think I've been really fired up about it. I was going to jump right into our content. Remember I said that well, I mean, I kind of did, but now I'm derailed. I'm just totally derailed, because I don't know if any of you have seen some of the news media about iReady. So I'm not going to go into that deeply, but what I am going to say about this is, over the years, we have states, not we, states have disapproved some of our testing entities, and disapproved some of our textbook companies, and disapproved and disapproved and disapproved. And for some of us, things that were working very well for us, and then reapproved, created a reapproval list of some things that I think are just pure trash. Now, I say that and you're like, okay, where's your data? Let me go back to sort of, this is not necessarily Saturday math, but one of the biggest overarching leads for scaling math achievement. And that is shifting. And we started to make this shift in about I'm going to say 2015, 2016, 2017. Then I think we were moving in the right direction. COVID came, and then everything went out the window. I don't even know what happened with decision makers. Like, I don't know if they're desperate, or if I don't even know. But what we have been moving toward ever since Minds on Math started this mission in 2011, what we have been moving toward is shifting math instruction to exactly how the brain learns. And decision makers and states are saying they're doing this through the science of reading, which there's a lot of merit to the science of reading. I'm not a literacy expert. I'm not an expert there. But here's where our downfall is going to happen. And this is my prediction, and this is what's going to happen. And this is why I want you all to be educated on this before it comes in and takes over and swoops in. The science of math learning is not parallel to the science of reading learning. Reading is a skill that must be explicitly taught. It is not innate, intuitive, inborn. But number sense is the exact opposite of that. We are born with a certain level of understanding of number. Number sense is intuitive, ingrained, inborn. It is a natural sense of the magnitude of numbers. Magnitude meaning how large and small numbers are. And so number sense cannot be explicitly taught. But number sense can be dramatically improved through experiences. So I want to catch us and educate us before some of these shifts come into place so we as educators can be knowledgeable enough to ask the right questions based on the correct current research of how the brain learns and how the brain learns certain things. So notation, notation must be explicitly taught. Kids aren't just going to discover what a square root is. So their notation is explicit, very much parallel to science of reading. Number sense is not. So when I share with you on Saturday sessions how to improve number sense, this all falls into a bigger picture of how the brain actually learns mathematics. And there are two different types of instruction and learning outcomes. One we call conceptual, which is the number sense piece, which students must experience and figure out on their own, but we must have powerful instructional delivery methods to be able to make that happen. That's what we focus on Saturday Math. And then there are procedural, algorithmic, math ability, notation, instructional delivery methods that are very traditional. Okay, so we need both. But these are competing interests because the more procedure and algorithm based we are in our classrooms, the less this conceptual can improve. But the more and more and more we work to improve the conceptual, the notation declines. So, what we do in all of our programs is find that right teeter-totter balance of being able to improve both because they are competing interests and they do require a different instructional delivery. Wasn't going to go into all that today, but I'm glad that I did because now we have it all pieced in one section here. My purpose of saying all that, though, was to talk about the purpose of Saturday Math, and it's always been to improve number sense. And that's exactly what we're going to be doing today as well. All right. Before I move on, though, that was a lot. Whoo! That was a lot. Okay. Unmute if you have other thoughts, questions, comments, etc. And I'll review the chat because I know some of you have been chatting in the chat. Chatting.
I had in the chat a neat story from an experience with my kids this week.
Please, yes.
It actually goes along with everything, how the brain learns number sense and notation were an absolute value. And so they were working on their lesson of the day and they were comparing some absolute values. And it was absolute value of -24 compared to absolute value of +24, greater than, less than, or equal. So I'm walking around the room and observing, what they're writing. And so many, of course, said the absolute value of +24 was greater. And I knew, exactly what they were thinking. But because, I've been with Jonily for so long, each kid I touched base with, I either said something like, tell me about that, or how did you get that answer, or tell me how you know that's true, something to that effect. And they know enough that they don't assume they're wrong when I say something like that. I just want to know how they got there. So they all just launch into their explanation, and every single one of them goes, oh, they're equal. Every single kid, every time. So I did this across both of my classes that day, probably a total of 16 to 20 kids that had, the wrong answer. But when I stopped them and paused them and didn't say, oh, you're wrong, how would you fix that? But how did you get that? Tell me about that. They launched into their explanation. They all self-corrected the answer. And it really got me thinking about like state testing in 2 weeks. I was like, you guys, you all knew the answer. You all knew it. I didn't say anything, but how did you know? Tell me about that. What did you think about that? And you all got the right answer. So my like takeaway and message to them was like, you know more math than you think you do. We have to slow because we've been talking a lot about taking your time on the test. And like, it's not taking time for the sake of taking time, but I was like, I want you to slow down your brain, have my voice in your head if you need to prompt yourself to say, how do I know? Or how did I get that answer? Like, take your gut reaction. Like, of course, 24 is bigger, but take that gut reaction and really evaluate the problem. And they self-corrected. But I'm like, what if they did that 5 times? That's like a whole level on a test. 5 questions where your gut answer and then you stop and think about it. So I'm like, that's the brain science, I think. Like, stop and think about it. And they know so much, but they just have to. So I'm trying to get my voice in their head, which is weird, but it was just a really neat experience. Like 16 to 20 kids, literally. And they all, oh, they're equal. I'm like, okay. So what a time.
But I have to give a good background on our friend Natalie, Krista, Amy, Sarah Neal that's here. Kirk, where is Kirk today? Oh man, I really needed Kirk here today. It's okay. So I want to share with all of you, and then we have Lisa, Sarah W, we have Daphne, we have Janet, we have. So the reason I'm naming these names is this doesn't just happen, like especially by coming to Saturday Maths. So we have at Minds on Math a math teacher mastermind group, which these names that I've mentioned are either currently a part of that or have been a part of it. The math teacher mastermind group launches into a math certification group. So Natalie, Krista, Amy, Sarah are all some of our certified coaches that have been implementing this for years, like years. Natalie, not as many years as others because Natalie got to be a student teacher for one of our certified coaches. So Natalie had an accelerated learning experience of this type of implementation. And the reason that I say all of this is it doesn't happen with one Saturday math or one math teacher mastermind or one implementation. It takes a good 3, 4, 5 solid years of interacting with this on Saturday maths, on math teacher masterminds, on June events, on certification programs, on, all of these things that we offer. And the reason I said April 24th, mark your calendars for April 24th in the evening. April 24th in the evening, we are having our next webinar. And this next webinar is going to outline a bundle package of all of our programs for 2026, 2027. So you can get all of our programs that we're launching, that we launch every year in a bundle at a very discounted rate. I'll send you information on that webinar. The registration isn't out yet. But the reason that I say that is it's all about interactions over time. And what I want to say about Natalie and her group is it's been about interactions over time all year. It's not just about the February, March testing season. If she just started this mindset and culture in February, there is no way her kids would have been there. But this was launched in August, what we call the first 15 at the beginning of the school year, so that kids by this time of year are ready. They're just ready for this. And I also want to say, I mentioned a lot of these names, Crystal as well. We had a big field trip, a teacher field trip. I wasn't even going to mention this today, but I have to because it was so powerful. It was so amazing. It was so enlightening and such an impactful experience for me that I want to share it today and have a few of you share if you were on the field trip with us. So, last month in March, we had a teacher field trip. There were 9 teachers that traveled to Central Ohio to my school district on one day and got to see my Algebra 2 and Algebra 1 classes, got to watch me teach. Then I arranged me teaching a class in fourth grade and second grade at our elementary school. So all 9 people shadowed me all day, watched me teach the same exact task to every class that day. And so the people that were there that day, and I don't want to forget anybody, Natalie West, Krista Ewing, Amy Garrison, Christy Flynn, Crystal Davis, Kirk was there that day. We had two other people that were there that day from another school. They're not here this morning. We had another Natalie and Jessica. I know I'm going to forget somebody. I don't mean to forget anybody, but let me know if I'm forgetting anybody. Anyway, all of us observed in the morning at the high school and then the afternoon at the elementary. I taught all of the classes, and then we had some reflection time and thought time, and it was in March. So I have worked with a lot of these kids and have trained a lot of these kids. So what you were seeing in a lot of these kids are kids that have had this model all year but came in with some severe deficits. All of the classes I teach are inclusion classes. So there's IEP students in every class that I teach. I don't have any advanced classes. I don't have any advanced. So when you look at these types of scores, it's just bad. But what we saw on field trip day is you wouldn't be able to tell that by March. And it's really spectacular to see. Well, then the next day, Kirk and I got to go to Natalie West's school and watch Miss Natalie. And then we got to go to Krista Ewing's school and watch Miss Krista. And I'm telling you, people, right now on record that Natalie and Krista teach the model better than I do. You guys, mind blowing. So I want to give you some background, especially maybe if you're here today for the first time, you don't know any of us, you don't know any of this. I want to give you some of those pieces. But would anyone like to share your takeaways from the field trip experience with us now? And I'm going to go back and look at comments. So unmute and let us know what your takeaways were from that experience.
Mine was, can you hear me? That's
Yes,
nice.
Crystal! Crystal!
Okay, so my takeaway was, and I shared this with you or with the group, was that no matter what grade a student is in, they can use their brains to think past just solving a problem. And you can take the exact same model and apply it at every level. And I thought that was amazing.
And I'm so glad that you all got to see that day. And I think that is more powerful than just seeing it at the high school level. Or because it's then, what does this look like in first grade? What does this look like in seventh grade? And same task, same instructional delivery model. Now, I tweak the way that I interact with kids because of the grade level, and you all got to see those nuances. But Crystal, you said it beautifully, and I don't think you can understand it until you actually see it or hear it. So if you have not had a chance to come and observe any of us, or you all have not had a chance for me to come and teach it in your classroom, or the cheapest, easiest way, if you all have not had an opportunity to listen to my audio files of me teaching these things with students, you need to make that happen because I can tell you all this. I can say all this. I can tell you, the people on here can tell you, but that hits different when you actually hear it done to students. So it was just a beautiful experience those 2 days. Any other takeaways from your experience being in all of those classrooms, Krista?
Yeah, the one thing that impressed me, particularly with the high schoolers, because I'm sixth grade, they allowed like the culture that was built through the methods that are being used. Um, they allowed like all of these strangers to just come up and we were asking them questions and it didn't throw them off and they responded to us. Um, and that's what, and it was the true of every class that we went to. We would just kind of all fanned out, looked at their work, asked these kids questions, and they didn't know us from anybody, and they were just engaged and willing to share their thinking with us. And that kind of culture is something that you have to build from day one. And it was just impressive the way that they just kind of acclimated to us as well.
And that is really unique. And I wasn't sure that they were going to be able to perform that way. These are kids that struggle. They have high anxiety for math. They've come with a lot of baggage from, and I'm not trying to blame, but from some ineffective instructional practices. They've been jaded, and I don't blame them. And I want to go back to what Crystal said. It's about going past the solving, because as I've said in our testing secrets launch this year, let me take a picture of this so I can erase it. But going back to solving is not learning. Solving is not learning. And if my emphasis in my classroom was solving, Krista and everybody would not have been able to experience the matheneering that was happening. So, what is the opposite of solving? It is thinking, reasoning, and sense making. This is the climate and culture that is going to scale math achievement. It's going to decrease anxiety, it's going to increase confidence, and it's going to improve test scores. A focus on thinking, reasoning, and sense making will always lead to solving, but we don't have to push solving. It will happen organically and naturally. And that's what Krista's talking about that she observed. And I wasn't sure. Like, I see it in my students every day. I didn't in August, September, October. It was like pulling wisdom teeth in these classes. Awful. I'm like, there is no way I'm going to be able to create this culture with high school students that, I mean, look at how many years they have not had these type of experiences. How am I going to do this? By October, November, they started to thrive and really come out of their shell. So for even me to see my students very vulnerable and taking risks in front of 9 adults, matheneering with them, heck yeah. Heck yeah. Um, and I keep saying matheneering. If you don't have the Making Matheneers book, go to Amazon, get it today. Making Matheneers. This is for teachers and students, improving the conceptual understanding of mathematics for the teacher and the student. Many different case studies in here of students and teachers and their journeys and how they've transformed to creating these types of environments and being in these types of environments in math classrooms everywhere. So yeah, get your book, go to Amazon, get your book, Making Matheneers. And it's really going to kind of lay out the foundation of the difference between this conceptual and procedural. So notation goes along with what we call math ability solving, okay? Number sense is this conceptual thinking, reasoning, and sense making. Now, I know what you're all wondering right now is, well, shoot, how do we create this in our classrooms? Saturday Math gives you pieces of that, but what you really want to do is go through one of our courses or programs so that you get that streamlined effect of what do I do first, second, third. But I'm not saying don't come to Saturday Math because you're going to get bits and pieces of everything. Saturday Math is much more non-linear, and very interactive, moving around. This is the big question that we have been trying to move in this mission. Before we talk about the how, though, and this is part of the content I wanted to teach today, before we talk about the how, we really have to talk about the when. And this goes back to textbook companies, some of these new approved, not improved, but these new approved textbook companies, the when and the structure of the year and how the content is delivered and when the content is delivered is the complete opposite of how the brain learns mathematics. So, what are some of our common instructional fails? Some of our common instructional fails are teaching one thing at a time, like a textbook is set up, focusing on solving, that's another fail. Treating all standards equal, that's another fail. Finishing everything. We haven't talked about that yet today. Finishing everything. So answering every question, solving every problem, that is a fail. We've got to let things linger. One of the biggest ways that we can improve math achievement is to let things linger. Ask questions and give problems that we don't finalize. Because what happens in the brain is the subconscious continues to think about that. There's this cognitive dissonance that we've never really tied the bow on. We really believe as a country and as a culture that we have to finish every problem. And I'm telling you that that is one of the worst ways to try to improve math achievement. We have to let some things linger so that the subconscious brain activates and continues to think, reason, and sense make without the human being even knowing it's happening. And that is probably the greatest fail of some of our textbook companies. So, how do we shift some of these fails into fixes? That is to look at the when. And I'm going to show you this on a document that I created. But before we even do that, before we even figure out how to do this, we have to figure out, okay, when, what's the structure of the year? And before we even do that, uh-oh, someone's asking a question about what curriculum. Oh, no. Oh, no, Janet, you're poking me, aren't you? You're getting me fired up, Janet. All right. Before all of that, we have to ask ourselves, what? The what is absolutely essential. And what is essential has to be exposed in 15-day cycles throughout the year. So, Janet, to answer your question, what curriculum would you recommend that does go with the brain research and is approved? None of them. Now, I'm not saying that you can't adopt things, okay? I'm not saying, because every single textbook resource, every single curriculum resource can be put in this model. Every one of them. Every single one of them. But we have to be able to be flexible and adapt how we use our resources. So these are the three biggest questions in our bigger program of delivery. The what, the essentials, the when do the essentials come up throughout the year? And it's in cycles of 15 days. And then the how is in the instructional delivery process that is going to have an impact on not only student achievement, but confidence. And yeah, I mean, Amplify, fantastic. I love and hate every curriculum resource. So I will say Amplify is very good, is very good in its pieces. I think the one thing that Amplify doesn't have, but actually it does, but it's kind of hidden, is the what and the when. I think there's a lot of great hows in Amplify. And yeah, so I'll just go from there. Okay, you all came to learn something today, though, but I'm really glad that I kind of gave all that foundation because I think all of that's important to continue to empower us to think differently about math education. Scores across the country are dismal. They keep declining. We've never had major improvements as a country. And we keep trying things that are not only not working, but are working worse than what we've done before. Oh boy. Okay, what a downer. What a downer. I don't mean to be a downer. Let me share my screen because I'm gonna okay. So these are the notes that I created for today that I'm going to work off of. And when I follow up email for you, I'm going to send you the PDF version of these notes so that you have these. This is what I basically just did on the whiteboard. That was intentional. But when I talk about the what, the essentials, you know it comes down to my F words. Love me some F words. So many F words, okay? But the essential math concepts that are going to build both of these, number sense and notation, are factors, fraction, and function. What do I mean by that? I don't mean we do a factors unit, a fraction unit, and a function unit. So what I mean by this is these are the three key concepts that should be a part of every 15-day cycle. We should always be teaching through factors, through fraction, through function. And what Crystal was talking about is seeing this effect at every grade level. So if you're a first grade teacher, Amy Garrison is a first grade teacher, Amy is constantly teaching through factors, fraction, and function, even though the word factor doesn't necessarily come until fourth grade in the standards. Factors are making arrays. So if I have 24 blocks and I make an array, I could make an array that is 6 tall, 4 long, or 8 tall, 3 long. Those numbers are factors. Kids don't know it, but making rectangles is one of our go-to experiences for students that not only improve number sense, but math achievement. So even as a first grade teacher, you are teaching through these three things. So our job as teachers is to learn what factors, fraction, and function look like at every single grade level and what the progression is from one grade level to the next. And what we do at Minds on Math is, and let me go ahead and draw this in. What we do at Minds on Math is we create reference tasks. We call them the Dirty Dozen. There are 12 reference tasks that associate with factors, fraction, and function. So if you're looking for lessons in your classroom to do to teach through these essential concepts, we have 12 reference tasks. The 12 reference tasks are exactly the same for every single grade level, exactly the same. There are some differences at kindergarten and at Algebra 1, depending, very, very minor differences and variations. But the reason we bring everything down into reference tasks is these are grab and go. Like, these are not theory. They're very practical steps to do lessons in your classrooms, and they are not a one and done situation. A reference task like making rectangles in first grade looks like making arrays with 24 blocks, and then how tall, how long are those blocks? What that looks like in fourth grade are, what are all the rectangles I can create? Well, actually, go to third grade. In third grade, what that looks like is, what are all the rectangles I can create with an area of 24, but different perimeters? In fourth grade, what are all the rectangles I can create with area 24? And the up level question to that is, what are the factors of 24? Because they are the length and width, they are the dimensions of the rectangles I can create. See, we're using that same task and we're targeting our standards, but what we're doing is we're front loading this progression, because as early as first grade, kids are learning about factors. One of our other tasks is a locker problem. This is an acted out, hands-on, concrete, conceptual situation that kids experience, that even at first grade, they start to learn the factors of a number, but we don't call it factors of a number. We call it which students touch locker 24. Oh, student 8 does, 3 does, 4 does, 6 does. Through these reference tasks are not one and done. So when I talk about these 15-day cycles, some of these reference tasks come back every 15 days. And then we up level them. So kids are getting interactions over time. They're getting more interactions with the same thing at more grade levels through these reference tasks targeting factors, fraction, and function. So that's sort of the framework, and it answers the what. Now, there are other pieces in this what, but it just comes down to those three things: factors, fraction, and function. If you study the College Board is ACT, or not, I totally said that wrong. I'm ridiculous. Got ACT on the brain. College Board is not ACT. College Board SAT, if you study that, there was a published book called Math Vertical Teams. Oh my gosh, way, way back in the early 2000s, I believe. In this book that the College Board published, College Board is the SAT people, in the book Math Vertical Teams that the College Board published, they said there are three things for students to be successful in AP Calculus, and it is rate, function, and accumulation. That very much relates to factors, fraction, and function. If you study what Algebra 2 teachers say that students need to be successful, they say radicals, that's factors. They say equations, that's function, or systems of equations, that's function. They say graphing, which is number line, factors and fraction. So everything that we are reading or studying or hearing about high school to higher ed comes down to these same things. And if you study math tests, ACT, SAT, end of course exams, grade level tests at each state, you study the national tests, NAEP, look at the TIMS report, study GRE. I've been studying ASFAB. So the tests that kids have to take going into the Army, going into the service. So I've learned more about ASFAB this year because I teach high school students, and I have some students that need to pass the math. And so I've been creating these. It's all the same. It's all the same themes. It all comes down to the same things. So no matter what textbook you adopt, no matter how the curriculum changes, no matter how the standards change, there are certain mathematics that are ingrained in the foundation that are priceless and timeless. They're never going to change. And that's what we base all of our programs off of. So no matter what comes and goes, no matter what's approved or disapproved, these certain essentials are always going to be there no matter what. If everything's important, nothing's important. And we have defined what is absolutely important. Now, I'm not today going to talk about the when. I set it up to talk about this today, which is how do we structure our school year? How do we separate it? And how do these 15-day cycles occur? I'm not going to teach on that today unless we have some time at the end, because here's what I want to teach on today. I want to teach on a practical example of everything that I've just talked about. And that is this equation. This equation, I pulled it right off of our state test for Algebra 1. Pulled it right off of our state test for Algebra 1. None of my students last week, when I gave this on a practice test, none of my students got the correct answer. And these are my students that have been ingrained in this model all year. So this is concerning. So what do we do about it? That's what I want to answer right now. What do we do about it? Well, I didn't start these equations early enough this year. We have another task called Jesse and Kay. I started Jesse and Kay much earlier in the year. I did not do enough fractional pieces for Jesse and Kay. Now, if you guys don't know what I'm talking about for Jesse and Kay, don't worry about that. Just ignore what I just said. If you know Jesse and Kay, just know that I made the mistake. I did not do enough fractional examples or variations of Jesse and Kay. And I'm seeing that now. So live and learn. So I want us to look at this equation. Whether you know Jesse and Kay or not, whether you know quick dots or not, whether you know that counting is essential or not, it doesn't matter what you know or don't know about this equation. I want you in the chat right now to do two things. I want you to type in what grade levels you connect with, what grade levels you connect with, and what you see and notice about this equation. So you're going to do two things right now. In the chat, I want you to type in what grade levels you connect with. So what grade levels you teach or coach or whatever. Or, if you're a principal or curriculum person, what grade levels you're in charge of. And what you see and notice about this equation. What can you tell me about? Tell me about this equation And what do you see and notice? Okay, let me look at the chat here. Oh, a lot of fifth grade teachers. Hey, I know why you're here. Hey, the fifth grade test everywhere, the hardest one. I'm telling you. You guys know this. There's reasons why the fifth grade test is most difficult for students. And we have solutions on how to fix that too. Good. This is excellent. Oh, okay. 1/2 and 1/4. Yeah, there are two X's. There's an X on each side. We see variables, fractions, lots of operations, hidden symbols, notes. Oh my gosh. You see why kids struggle with coefficients. Yeah, you've got to have the ability to work with fractions. I mean, kids are going to look at this on the test and be like, nope, skip, next question. Just because there's a fraction. There are constants and variables, unlike denominators. Yeah, Amy, really good point. You would cover up those X's with smiley face emojis. Yep. And just say these are the numbers we got to try to figure out. Yep, perfect. Constants and coefficients. The mixed number. The mixed number. That was weird for me too. And then I went back to previous year's test release questions and I'm like, there's a few of these with the mixed number in it. There's a lot of these in fifth grade. A lot of these in fifth grade. Yeah, the X being a multiplication symbol and not having no concept that it's an unknown. Yep. Yep. I mean, there's so much to lose with this question. Yeah. Okay. Okay, let me stop for a moment. We're going to come back to this and I'm going to walk us through instructionally what we do with this. Instructionally, what we do with this in Algebra 1, knowing my test is in a week and a half. Instructionally, what do we do with this at third grade? Because this is like perfect third grade, not equation solving, but like third grade content. And I'm going to show you that in a moment. But go ahead and unmute and talk to me about instructionally, how do we deal with, how do we improve, how do we use this example in a conceptual way to improve number sense and to help students think, reason, and sense make and not solve? You've probably never thought about equations this way, but unmute and talk to me. What are your ideas of using this equation that looks very traditional, very notation-ish? How would we use this in a conceptual, contextual way such that kids are thinking, reasoning, and sense making and improving number sense at the same time? So there's a way to notationally, procedurally, algorithmically, there's a way to solve this equation. But if that's the only thing instructionally we ever do with this, we're never going to make major gains. So what would we do instructionally, conceptually, to teach this? Talk to me.
So the first thing I would just ask is, and I learned this from you, Jonily, is what do you notice?
Beautiful.
What do you notice? What can you tell me?
And then this is what's scary because they're going to tell us things that we weren't expecting, and then we have to responsive teach on that. Do you see? So here's what I want you to think about. When you use the tell me about, what do you notice, what do you see, do not have an expectation for yourself to teach on it. That's why we want to let things linger. We want to ask those prompts. Document, even in writing, on a poster paper or on the board, document what kids are seeing and noticing. Respond with That is brilliant and that is interesting. I love the way your brain thinks. Ooh, I've not thought about it that way. We're celebrating the thinking. That's the only responsive teaching we're doing on the day that we give it. And then after we do that for about 7 minutes or so, maybe 10 minutes, we then put that away. We move on to what our regular lesson is of the day. Then we have time as a teacher to create the responsive lesson based on their responses. Don't try to do it in the same lesson or class period. That's what freaks us out. And that's why some of us are afraid to implement some of these strategies is we think we have to then create the responsive lesson on the spot. We don't. Let all that linger. Don't even come back to it the next day. Wait a week to come back to it. Email me and say, here's a picture of their responses. What do I do next? I mean, that's the interactions I'm talking about with this transformation that we're trying to make instructionally. And then what now? And then what? So what do we do then when we start to teach later? How would you teach this?
With my third graders, I would probably ask them, do you think it's going to be a whole number? Do you think it's going to be a fraction? I would, do you think it's greater than, less than, or equal to a certain number within the equation? Just to get their kind of general understanding of things.
Yeah, that's really a different way to do estimation. That's a really great, powerful twist on estimation. Love it. What else would you do? Yeah, good. Krista even brings in a good sentence starter, question starter. How does the right side relate to the left side? Beautiful prompting. What else would you do? You're probably afraid to say of what you would do. Think I'm going to judge you or something. Don't be afraid. Don't be afraid, guys.
I use algebra tiles when I'm introducing stuff like this. So I've always tried to encourage my kids to draw it. We've been trying. I have the same problem, and thanks to you, I'm not like totally losing it because I've been given a practice OST question a day, and like my test is Monday, and yesterday they this one prompt, 2/3 of my classes got it completely wrong, and I'm like, ah. So I took a deep breath, and I was like, all right, tell me how you got that answer. And I'm like, tell me what, and so it was so interesting because I said, tell me about, I got thinking and I'm like, gosh, you guys knew this. So my thing is we're doing this like incentive that they take the test and I look at their answer papers, like with their work. And if they do it their way and then do it my way with other strategies, then they get to go to this extra recess. So that's kind of cool for seventh graders. But the push is the thinking. So we've been doing, like you said, stop. What do you notice? What do you wonder? Then answer. And I've been withholding their calculators to say, okay, think about this first.
Yeah.
Now you can have a calculator because
beautiful.
it would grab the calculator, go, I'm like, you didn't even think about that, guys. So that's what I'm trying to, like you said, sit and think. But I would have them draw a picture, and what do they see when they draw the picture?
Beautiful. Janet makes a good point that was a little bit of a hidden message in there, and that is all year, if students' experiences every day in our classrooms is solving, we're training them to not think. See, if we have less emphasis on solving all year, if our lessons are structured every day for thinking, reasoning, and sense making, and that's what we prioritize and that's what we celebrate, then we're going to change their habit. They're not going to be able to help it but to look at a test question and think, reason, and sense make before they solve, because that's the culture and climate every day. And I can tell this, we have a brand new fourth grade teacher in our elementary school, and she is phenomenal. She came to our June event last year. She's fresh out of college. She started teaching fourth grade this year. I didn't get to work with her a lot, but she came to the June event, and we have another like intervention coach at the elementary that's been supporting her because I haven't been able to do that. Well, I've been in her room a few times just in the last month. Her room was one of the rooms we went in when we had the teacher field trip. And I can tell her kids have been trained by her really beautifully because I see her kids doing thinking, reasoning, and sense making. So when I went in just on Thursday this week, because I went back twice this past week, when I went in Thursday, I gave them a question and we talked about pretend this popped up on your computer on your test. And this is fourth graders. What are you going to do first? And they're like, we're going to look at that piece of it. We're going to ask ourselves, what do we see? What do we notice? And what do we wonder? Okay. Now, whether they do this or not is one thing, but the fact that they can at least articulate it is going to train their brain to look at mathematics in that way, not as a solving exercise, but as a thinking exercise. And then one of the outcomes is we're going to get a solution eventually. But we've got to make sense of it first before we try to solve anything. And so you talk about effective test prep. That's effective test prep. Other thoughts, comments, questions?
I've been doing that this week with test questions where I haven't given them or worked through an answer on any of them. It's just,
Nice.
this is what comes up. What are you going to do? How are you going to attack it? What's important? What kind of strategy? What does the model look like? And then if they decide, I'll give them candy if they come to me with the answer by the end of the day, because some of them can't help themselves. But we haven't, solved any problems. We've just been like attacking them and like getting to that understanding part. So, yeah.
I know we're just crossing our fingers at this point. Janet, I'll be saying a little prayer for you guys on Monday morning. Wow, that's like in 2 days. Okay, fantastic. Anne, yeah, fantastic. Yeah, really great prompt. How can you start? Look the same. Yeah, okay, so this is really good because you guys know me. These are some of my favorite early grade, I don't want to draw, I want to type. These are some of my early grade equations that I even give to my secondary kids. We have something like, let me get bigger here. We might have something like, oh shoot, this is gonna be a bad one. Okay, hold on, let me think. Let me think. 3 plus 8 equals blank plus 5. Okay. Okay. So this is something that I do specifically at the earlier grades to promote unknowns, equivalence. This is more of a thinking, reasoning, and sense making prompt than it is a solving prompt. I know if kids have been trained to solve or reason, and those are competing interests. I know if kids, like in a fourth grade classroom, have been trained to solve or to reason by giving this prompt. And if kids put, I'll draw now. If kids put, what is that? If kids put 11 here, I know that their instruction has been highly solving. The priority is solving. I know that they believe that the equal sign is an answer getting symbol. They do not understand equivalence and representation and balance and same as. And they don't understand that these are two different situations that need to be exactly the same. They don't have any idea same as. That's really what equivalence is. So if we want to promote thinking, reasoning, and sense making with equations, we need to talk more equivalence and balancing and structure than we do solving. So this does not create this does not create the same thing on both sides. So one of the things that I do is I give this equation, do a tell me about, then I give this one because this is kind of a precursor to understanding what's happening in the other. Yeah, very good. Great, great comment there. Yep. Amy, you good? You good? Did I give you a good takeaway today for your, yeah, see? See? Amy, good. When we read that in class, we always say 3 plus 8 is the same as blank plus 5. See, yeah, Amy, and Amy teaches first grade. Yep. Amy's always wants us to get to those numbers. Now, let me go back to this. Let me non-draw. Let me get okay. Now, because I'm in a desperate attempt to make sure my kids do know how to solve, here's what I did yesterday because I'm like, you guys, you know how to do this. Because if I give them, if I give my kids equations like this, they're not putting 11, okay? If I give kids equations just like this with variables on both sides that don't have fractions, they can solve and be accurate 98% of the time. So this is frustrating that they just freak, that they totally freak. So this is what I did yesterday. I did the traditional. This is Algebra 1. They're going to take the Algebra 1 course. And I'm like, what would you do? Like if there weren't fractions? And they're like, oh, we would take away 3 from both sides. I'm like, okay, well then why can't you do that? And they're like, well, we can. I'm like, well then do it. Like, what the freak are you doing? I think I said that to them. Now, this is important. When we take away 3 from both sides, I always say to my kids, what's the point? What's the purpose of that? What did we want to try to do? They're like, well, we wanted to remove this 3. We wanted to like move it to we wanted to remove it. How do we remove a plus 3? What goal do we want to get to remove it? Well, for a plus 3, we want to get to a 0. This goes back to, and I've taught on this numerous times, the importance of zeros and ones. The importance of zeros and ones. So if I want to get rid of, eliminate a plus 3, I have to make a 0. I have to make a 0. Now, if I have 3x and I want to eliminate a times 3, I have to make a 1. So there's many trainings that I do that I talk about the importance of zeros and ones in mathematics. So here, let's say the half wasn't there. 13 minus 3, 10 and a half. Okay, so what's the same as? What's the same as now? So we've got x over here equals 10 and a half plus 1/4 x. Here was another problem I gave my kids last week. I said y equals x over 4 plus 7. Okay. And I said, what's the slope? Now, my kids know that y equals mx plus b is a linear function, degree 1. They know it makes a line. They know that when x is 0, you have a y-intercept. So it's going to cross the y-axis at 7. That's the 0, 7 point. But this trips them up because of the way this is written. The way that this is written, they want the slope m to be 1 because the coefficient of x looks like it's 1, but it's not. So you have to understand the different representations that this actually means this. So because I had done this problem earlier in the week, I brought this back and connected it to this. So the more connections we can make to other types of problems, the better associations they're going to make as well. So now we're boiled down to this, and then my kids are like, oh, well, we need to get the x's. Okay, now what they wanted to do here with the plus 1/4 x, they wanted to multiply by 4, which is great if I wanted to get a 1. Now, I did the multiplying by 4 and I entertained them with that. And then I said, okay, then we get 4x and we get this multiplied by 4. And then over here, what do we get? And they're like, well, that went away. No, it didn't, because 1/4 times 4 is 1. Now I have 1x over here. Now I have 4x here. But it's okay. We don't have to go backwards. We can multiply everything by 4 and it's just fine. That's legal. But we could have done something else that is going to put our x's together. Okay. So if we think of this as our chunk and we want to remove this chunk, we have a plus chunk again. How do we get rid of a plus chunk? We minus the chunk. Okay. Now I'm being very traditional here, blah, blah, blah. But I want to make this point and then I'm going to stop with this traditional nonsense. Here's the point I want to make. Now, my kids know that this is not 0. Many Algebra 1 students think that this is 0 minus a fourth. And I'm like, but how many x's? What's the coefficient? It's not written. It's 1. You actually have 1x. Now, this goes back to what Janet was talking about. Because if you use algebra tiles, these x terms are green rectangles. A green rectangle algebra tile has a height of x and a length of 1. We call the area of this, we call the name of this green rectangle x. So if I want to represent 3x, I would need this x and I would need 3 of them. Now I could draw 3 rectangles, but I teach my kids to shorthand this. There are 3 rectangles. That's what 3 x's look like. So over here, I have 1x. So I just have one of these here, which shows that you have the coefficient of 1 and not 0, because there actually is 1. There is a green rectangle. Over here, oh, I don't even have a whole green rectangle. I have a fourth. I didn't draw that very well, but you get the idea. Okay. So this is how much I have of that rectangle or that paper strip or whatever it is that we're using that gives that conceptual, concrete, situational, contextual, visual to this equation. Now, I'm going to go ahead and stop here because my kids also were successful once they know that was 1 minus 1/4 is 3/4. Now, I'm not going to go any further with that traditional because here's what I want to do. Oh my gosh. Okay, fine. I'll do it this way. Okay, let's go down here and start over. Okay, now, what my students in 1st grade, 3rd grade, 4th grade, 6th grade, 8th grade, algebra, what my students know at every grade level is equations are Jesse and Kay money. So this side of the equation is Jesse's money. And so this side of the equation says that Jesse starts with $3. And I know that that's the starting number for Jesse because that's when X is 0. That's on day 0. When X is 0, Jesse has $3. That is also y-intercept. The y-intercept of Jesse's linear function is 3 because a y-intercept happens when X is 0. Now, I'm not telling 3rd graders this, but I'm telling you this because you can use X as this is, and you can notate it however you want. This can be how much money Jesse or Kay gets or loses every day. And that could just be your, emoji number, whatever you want to call it. The number that doesn't have that variable or unknown, that's called a constant. And that's the starting. It's +3. So Jesse starts with $3 a day. And then how many of these were there? There were 1. So Jesse gets $1. She earns $1 every day. Now you could say that this is the rate and talk about rate, speed, 60 miles per hour, but you don't have to. You can just say that the way that this is notated, that means because there's 1x, that Jesse's going to get $1 a day. So on day 0, Jesse has $3. Day 1, Jesse has $4. Day 2, Jesse has $5. Day 3, Jesse has $6. This is the model and mindset of instruction in Singapore. What they do in Singapore is they give typical Algebra 1 questions to elementary students, but they frame it in a context that allows access for first graders, third graders to do an equation like this, but in a different way that's going to target the standards at elementary. Now, we at Minds on Math, we add a different level to that. We reference task it, we contextualize it as a Jesse and Kay problem. So now if I go over here, let me do a different color, and I'll save this and I'll send you these notes. If this is Kay's money situation, what's Kay's starting number? Kay starts with $13.50. Now, what we might say is, oh, that is $13.50 if kids want to do it that way. Okay, so K starts with $13.50. Now, what I could do at this point is ask my students, what math questions can we create? And so some of those might be, who starts with more money? Who gets more money? Who loses money? Who this, who that? Okay, how much money does Jesse have on day 100? How much money does Kay have on day 100? So if I line this up, when this number is 0, when this is 0, when this is not there, when the 1/4 whatever, no days have gained any money yet, this is day 0, I start to line up this relationship here. So now this one is harder. K is harder, I admit. So on day 1, we need to know how much money K has. But how much money is K gaining or losing every day? Well, K is gaining money. So K is gaining money, 1/4 of a dollar every day. 1/4 of a dollar every day. Well, how much money is that every day? Okay, well, we can leave it in fraction, or we could say K is getting 25 cents. Come on, I'm trying to do this with my just mouse pad. Come on, Jay-Z, make a 2. Okay. Ha ha! Ha ha! Okay. So K is gaining 25 cents, 1/4 every day. Now, if you teach second graders, third graders, and you're trying to get them to understand money, what a better way to do money than to embed it in a situation that is very algebraic thinking, very skip counting-ish, very rate infused, that is grounded in unknowns and equivalents. Like, look at how many birds you're killing with one stone. Not that I advocate for killing birds, but I advocate for efficiency of instruction. I advocate for using one example, one situation to teach lots of different standards. And when Crystal said, I saw the impact of the same task, the same thing, no matter what it is, being done at every grade level and being effective and powerful, this is what Crystal is talking about. So on day 1, on day 0, if K had $13.50 and we get 25 cents more, then we have $13.75. And let me know if I make a mistake mathematically, because I do that a lot. On day 2, how much money does K have? Well, we add another 25 cents, $14. On day 3, how much money does K have? $14.25. Or I could write 14 and 1/4. I can go back and forth on variations of representation, doesn't matter. Okay. Now, after we're doing this together as a class, I'm going to then ask again, say my favorite words, tell me about what you see. What do you see? What do you notice? Make sense of it again. We're going to stop. And we started to kind of like do some solving and counting. And so every time we start to move to solving and answer getting, we as the instructor need to back up and say, wait a minute, how do I bring it back to thinking, reasoning, and sense making? So I get this started and then I say, tell me about what do you see? What do you notice? in the chat right now, I want all of you to type in, what do you see and notice about what just happened? So type that in the chat. Tell me about this structure. Tell me about these numbers. What do you see and what do you notice about what just happened? What are your thoughts? Come on now, chat it up. Oh, nice. Both sides are increasing at the same rate. Good. Yep. Another thing I ask my students as they're thinking, reasoning, and sense making is, what other math questions could we ask? Nice. J is increasing faster than K, even though K began greater. So what does that mean? What does it all mean, Basil? Nice. Yep. Will J end up with more at some point? And when Crystal, yeah, this is amazing. Oh, yeah. Okay. Okay. Now, here's where your default instruction is going to kick in. If you do this in your classroom and you get to this point, your default, because you have habitual traditional instruction, what's going to happen now is you're going to have kids keep extending and you're going to have them answer these questions. What I'm telling you is, don't. When you get to this point in your instruction, in your class, you're going to be like, okay, that was so beautiful today. I'm so proud of you guys. We realized a lot of different things. We're going to put that away, and I want you to take out yesterday's homework. That has nothing to do with this. Okay? I want you to go on to your regular lesson. Now, if you leave here with nothing else today, I want you to hear me on this. You're going to be like, oh, but the kids want to finish. Well, the kids want to keep going. I finally got them focused and engaged. Then cut it off. There are brain reasons for this. There are cognitive reasons for this. We are shaping the brain and we are shaping the mathematical mind. So right now, as soon as you have the kids in the palm of your hands, as soon as you have them right where you want them, you're going to stop and you're going to be like, okay, we're going to put this away and we're going to go on to our lesson of the day. Now, you're going to have kids still working on it and trying to hide it. Don't call them out. Just ignore it. You're going to have kids still talking about it. You're going to have kids going, oh, but I know we're da 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 da. They're going to go do math without you asking them to do math. How amazing is that? They're going to talk about this at lunch. They're going to come in the next day with the answer. And when they give you answers, you're going to be like, that's interesting. You know what? Let's start adding that to an answer list. Let's start documenting that. We'll come back to this next week, but let's celebrate what they're doing. But do not confirm or deny their answers. There are some responses that are going to negate all of the work that you've done. You want to let this linger. See, I'm going to let this linger. You're going to let this, Lisa, beautiful, beautiful. Because that's what we end up doing with Jesse and Kay is we graph Jesse's system of equations. That's what this is. We graph Jesse's function, we graph Kay's function, and that's just good practice in slope intercept, like boom. And then we start asking, are we going to have parallel lines or non-parallel lines Parallel lines have same slope, no solution. We don't have the same slope here. So we are going to probably have a solution somewhere. What is that solution? Is the solution going to be in the future or in the past or in the negatives? And what is this? So much we can do at Algebra 1. And Lisa, imagine if your seventh grade, sixth grade, fifth grade, fourth grade, third grade, second grade, first grade teachers in your building did Jesse and Kay every year in lots of variations. So by the time kids came to you in Algebra 1, they've already had a lot of this mentality. Can you imagine what that would look like? It's really beautiful because the cohorts, I got rid of the data here, but the cohorts where we've seen this extreme data, that's what we've been doing in schools. And we've earned 15, 20, 30, 40% higher test score rates by doing exactly this. All right, friends, it is almost 11. Here's what I want to hear right now. Type it in the chat or unmute. What were your takeaways from today? What were your ahas? What are you going to take away from today? What did you learn from today? What solidified your learning? So, what are your takeaways? Unmute or type them in the chat or both. Go ahead.
I just have something about the field trip. Um,
Yeah.
I'm going to bring in another reference a task, but the painted cube. So I had the block that you were in with came back on from spring break on
Okay.
day, and one of their first questions to me was, "Hey, are we ever going to do that cube problem again?" And not only that, but then my other block that they kind of intermingle with was like, "Hey, I heard that you did this cube problem. Like, are we ever going to have a chance to do that again?" So, they've been talking about it. It's just interesting.
That's cool. That is cool. Lingering is so powerful. Let it linger. Other takeaways. Hannah says, teach based on thinking more than solve. Yeah, beautiful. Other takeaways. Yep. Thinking, reasoning, and sense making is the key. And only that's not on the kids. That's not on the kids. That is on our instructional facilitation and delivery. So if kids don't have thinking, reasoning, and sense making, if they don't persevere, if they don't initiate, that's on us, not on them. We have not created the environment, culture, and habits for them to default to thinking, reasoning, and sense making. A lot of times I hear these kids, they just don't start. They don't know where to begin. They're so helpless. They're da 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 da. They didn't do that to themselves because toddlers don't have any of that. Toddlers don't have any of that affectiveness. School has created that in our students. That's on us, guys. That's on us. Get students' brains thinking, leave them hanging. Yeah, that's important. Focus on factors, fractions, function, and we have more explicit, streamlined approaches to being able to focus on those. Yep, very good takeaways. Balance between procedures. Yeah, just do it. Like, just jump in. Don't be like, you don't know what's going to happen as a teacher. I know that's scary, but I've given you the out. Once you get to a point where you don't know what to say and do next, and you feel yourself defaulting to telling and teaching, then you want to stop and be like, hey, we're going to finish that another day. Insisting that my students pre-read, understand. Yeah, yeah. What is it asking? Think, reason, and sense making. New way to word. Make rectangles now. Okay, good, good, Amy. Yeah, and you're going back to third grade. Awesome. Oh, that seems like it's going well. That's excellent. Wonderful. Okay, you guys, I've got a pretty hard stop today. Usually we stay on and I give you some more time and then like all of you end up staying for like another hour. I can't do that today. I have a hard stop time today. Although I love you. I love you so much. Mark down April 24th. There will be the next webinar. A webinar with upsell. Saturday maths, I usually don't have any upsell. I mean, this is just real organic. Like Saturday math is free. There's nothing I'm selling to you. But on April 24th, there will be an upsell and it will be a bundled package of what you can jump into for the 2026-2027 school year. I really want you to be here on April 24th, but I can't give you any link right now. Nothing is up for registration yet. It'll be coming up later this week. So I will send you the information for the April 24th webinar this week once I have the link. I'll follow up and send you the notes from today, the PDF notes from today. And I want to thank all of you for being here and spending your Saturday morning with us. We will have another Saturday Math in May, and you will definitely get that information also. Love you guys. Bye-bye. Good luck with testing. Enjoy the final 30 some days of school and have a great summer. But hope to see you in May. Bye, everybody.